Okay, well, so we have another problem, which is actually really nice problem that I like with, and then I received this from one of my students. So it's a logarithm problem, but at the same time, it's just kind of asking us to see some sort of identities as well. Okay, so let's actually dive into. So we are given ABCs as real numbers, and then we have three logs, and their sum is like 0, and we are looking for the cube out those logs. Okay, so it doesn't really look nicer to work on with those logs, I guess. So which is why I'll just do some substitution first. I'm gonna say, let's say this is x and this is y. Let's say this is z. So based on this, x plus y plus z is 0. That's given. And the question is asking x cubed, y cubed, and z cubed. And so whenever you see like some third power, maybe second power, maybe some other powers, and they have the same exponent, so you probably want to see if there is a connection, relation between what you are given and what you are looking for. So like we have like seen the sum of the cubes, right? When you have two variable like x cubed plus y cubed, but we don't really see the sum of three perfect cubes, right? But now it's given in this case. So then I'll try and see if I can find maybe another identity or maybe a relation between those two. Okay. So here's my hope. So when I see the sum of these guys, and I like to find the relation between these two, right? So I am hoping they're the x cubed, y cubed, z cubed, like their sum is somehow will give us a factor of x plus y plus like z. So we can actually see 0 times something, which is going to eliminate a lot of work. Okay, so that's my hope. Okay, so if I write this x cubed, y cubed, and z cubed, so I'm just trying to guess and hope this is equal to sum of these three plus something. Okay, so in order for us to get x cubed, I need to multiply, actually like x by something right here, so I can get x cubed. So that something should be x squared, and the same reason I should have y squared and z squared as well. Okay, so now we have these three in my second parenthesis, but here's the problem with this. If I multiply this by this, I will get x cubed, which is right here. That's perfect. But if I multiply this by that, maybe I should write so we can see those. If I multiply x by y squared, I get xy squared. If I multiply x by z squared, so that will be x z squared. And the same thing with y times x squared, and y times y squared is y cubed, we already have. So y times z squared, and then z times x squared plus z times y squared. So these are the 6 terms we are going to receive if I multiply x by like these terms and then y by the same thing. If you keep multiplying, so you are going to get these 3 terms for sure, but at the same time, you are going to actually get 6 more terms like this, which is you don't have on the left side. So somehow you need to cancel this. Only way that we can cancel when you multiply with the positive terms, you should have a minus version of these guys on the right side in that second parenthesis, so you can maybe cancel those. So if you want to get this term, okay, so you want to multiply y by xy, right? So you have y right here. So if you had negative xy right here, then that would be creating this guy, which is the negative version of that. So then they will cancel each other. So then I will say we should probably have xy right here. With the same reasoning, we should have xz, we should have yz as well. Okay, so let's confirm that. Okay, so if I multiply x by negative xy, that will be negative x squared y, and which is let me see, where is that? So negative x squared y, right? So right here, that's the positive version of that. So this guy will cancel when you multiply this by like this term. When you multiply this by this, you get negative x squared z, which is gonna cancel this one. If you multiply this by this, you get XYZ. Okay, that is a challenge now. So if you multiply X by this, like X by YZ, you actually get minus XYZ, which is maybe another thing we need to think about. So let me just write it as well, XYZ. And if you multiply Y by maybe XZ actually, so you know, if you multiply this guy by this, you actually have another minus XYZ. So that's interesting. And then we have the same thing with ZY, Z by XY, which is also another XYZ. Okay, so that's fine. So when you multiply, so those are the terms that you are going to receive, right? But at the same time, so those 6 terms, like these 6 terms will be canceled with the, when you multiply these 3 by these 3. So 6 terms will cancel and only these terms will be left over. But at the same time, we're going to get 3 of these same terms as well. So which is okay. So we are not going to able to complete the factor, but at the same time, we were able to get something out of that product. So I can just write minus 3xyz. So I hope that makes sense. Again, if this is something you didn't really get fully, so I'm going to ask you just stop at this point and maybe multiply the right side and see if that's really the same as the left side, okay? But now I'm going to say this is actually our another identity that you might be seeing sometimes, okay? So I just didn't like this one, so let me change this. Okay, so, and I'm going to just put it this way. So again, this is just another identity, which is sum of the 3 cubes and is equal to like the sum of those 3 terms and times something, okay? And it doesn't look too bad because you have kind of symmetric like expression on the right side, okay? But anyways, if you don't like to memorize this one, just use the similar process using this now, then next time will be a bit easier to remember what to do, okay? So let's plug now our numbers into this identity. So based on this, I can just go the log. Okay, so the log base A of B to the third, and the log base B of C, I guess, to the third, and the log base C of A to the third is what we are looking. So now I'm going to just put those back into identity. So that would be X plus Y, which is this plus log base B of C and plus log base C of A times something. Okay, so again, I'm going to ignore this part because you see that you can just write those, but you don't really need to, just because we are given the sum of these 3 terms was 0. So which is, you know, this was given 0. So since this is 0, 0 times something is just 0. So you don't really need to deal with that at all. But make sure you have minus 3 times xyz at the end. So 3 times xyz. And then x was my log. So maybe I will write it here. So minus 3 base A of B times B, which is, I mean, Y, which is log base B of C, and times log base C of A. So maybe I should write minus 3 over there. So again, this is just this minus 3xyz. So since there's no place right here, I just wrote it there, okay? Anyway, so the question became now, so since this guy was 0, so 0 times something is 0, so you will get just negative 3 times the log base of A times log base B of C, and the last one was this. Okay, so if at this point, if you don't remember the base change, I'm going to remind a bit now. So whenever you have something like this, okay, so log base A of like B, and you can actually change the base of this log into any bases based on what you need. So I can write this guy as, let's say base will be X. So that would be argument now is B, and this is gonna be the base X and argument will be A. So this is called the base change. So again, if you are not familiar with this, so it's better to review this as well. Okay. So now if I just apply this in my problem, so I will be done actually. So that will be -3. Okay. Actually, this was a -3 because, okay, this is actually +3. Okay, because when I multiply, like, X by this guy, for example, I got minus X squared Y. Okay. And when I multiply this by this, I got minus XYZ. And then when I multiply Y by maybe this guy, you got minus XYZ. When I multiply this by this, I get minus XYZ. In order for us to cancel those, I should be actually adding plus version of those. So that's plus. So I missed that somehow. So that's a plus, but I remember that. Okay, anyway, so that's the +3. So for the log base of B, I can write it as log B over log A. So basically I change the base to the 10, and that would be log C over log B, and the log A over log C. Since these guys will cancel, these guys will cancel, these guys will cancel, so you just get really nice answer. Okay, so we did all these work for just getting a integer, which is good actually. Okay, so I hope that makes sense. So that's the answer.